inverse trigs are, we already mentioned them before, but if you don't know, don't be afraid. We're learning it from scratch. Sine minus 1x or arcsine x. That's the inverse of sine. Both notations are internationally known and I think equally used. I don't see the pattern of people in the articles or books using one instead of another one. It's usually personal preferences. Arccosine x is cosine minus 1, and so on. We're going to do 2. Arctangent x. Are we going to do arcsecant? Let me see. I think we do arcsecant 2. Sine, cosine, tangent. No, we do sine, cosine, tangent. Those 3. It is, guess what? Arctangent. Do you know, I clearly want to make it very clear. This is just the name of the function. So the function was created to undo sine. Sine x. But instead of x, we're applying sine minus 1. X gives you x. So they're undoing each other. It's like dressing up and undressing, right? They undoing each other with some restriction on a domain, which we're going to talk about later. This is the name of the function. When they create inverse of sine, they just decide to call it somehow. And they call it sine minus 1 or, as I already mentioned, sine of arccosine. That's the same thing. And I'll be changing them randomly. I don't even keep track what I'm actually writing and what I'm saying, because that's how equal they are in my mind. Yes?
Oh, I have a question about the last question.
Oh, the previous question?
Yeah.
Okay. Oh, I don't want to simplify it, yeah. Because I have video solution on this, and because I'm just got bored a little bit. Where was it? It was this one. This one?
Yeah.
What's the question?
How do you simplify that?
I can mention actually, that's not a bad question at all. I will do 2 times 4, that gives me 8 over 4x minus 4. I would put in numerator, you don't have to, but it looks nicer. Plus 2 times 10x becomes 20x over 5x squared plus 2. That's all what I do with this right-hand side part. And then y, I just copy it. 4x minus 4 squared times 5x squared plus 2 squared, so on. And this is the answer. Like, this is good enough. No need to simplify more than that. No need to distribute, nothing. Actually, people quite like to have a factored form. Does that answer your question?
Yeah.
Okay, thank you. Yeah, very good question. So, with inverse trigs, I already mentioned to you that it's a name. They could just leave it inverse of sine, but they call it arcsine. It's a name. Instead of f of x, g of x, it's called arcsine. So that's kind of interesting that some functions have names. And your job is to know derivatives of these known functions, which are, I'll write down the most important ones, and then I'll give you a table of others. What is derivative of arcsine? Arcsine prime. So you will notice I say arcsine, but write down sine minus 1, because arcsine is 1 English word, while sine minus 1 is 2 English words. 3 English words. So I say 1, but write down another one. It's just a habit. Derivative of that, and I'll change it into u for u, because most of the time you will have chain rule involved. It's not going to be x. It's going to be 2x, log x, and so on. The formula says 1 over everything, square root. Isn't it beautiful, right? It's getting worse after that. 1 minus input squared. Input squared. That is the formula. And then, of course, because it's a chain rule, you will do times u prime. But I will leave it as it is right now, not to mess up with you. Like this. This is the formula. And then you do times u prime, chain rule. But that's not part of the formula. Part of the formula you need to memorize is 1 over square root 1 minus input squared. For the arccosine of u prime, you will have the same but negative. Oh yeah, we need to know arcsecant, now I remember. It's negative 1 minus input squared. So just like with sine and cosine, that's one at least is easy to remember. The only difference is negative. I'll put negative in front. Like so, x cannot be plus or minus 1. Do you know why u cannot be plus or minus 1? Yeah, I cannot divide by 0. And because it's squared, you have to exclude plus or minus 1. And right after this, I will do secant because they will be asking you for secant. The beginning of Calculus 2 class pushes you to know those derivatives. Just like you wake up in the middle of the night, you have to know them. If I ask you in the middle of the night, calling you by phone, and I will say, Eric, wake up, Eric. Do you know the derivative of secant? You're supposed to know it. That's how bad it is. Secant, well, it is arcsecant, right? Of u prime is, do you know what's confusing? It's exactly the same beginning, but it's input squared minus 1. Input squared minus 1. So, I don't know, there's no way for me to tell you how to remember it. You can use triangle if you want. I remember it in a dumb way. Sine starts with 1, while secant does not start with 1. So the only difference between these two is the order of u and 1 inside of the square root. The tangent is going to be your favorite. Arctangent of u prime equals 1 over no square root u squared plus 1. And that means the order doesn't matter, finally. So you can forget the order, at least for this guy. Put it in the box. You need to know these 3. Arccosine is rarely happens, but it's also easy to know it. But you need to know sine, cosine, secant. Secant, well, I mean arc inverse of sine, cosine, and secant. Do you remember what secant is? That's actually a good question. What is secant? 1 over cosine. So arcsecant, oh, wrong place. Arcsecant is inverse to secant. That just makes sense. Now you can start your homework after that, because that's literally what we're going to be torturing you with. Note. Let me put note at the very beginning. And someone asked it last time, so I made this note before. Note. Sine minus 1x is not 1 over sine x. That is reserved for the inverse functions. So people just don't write down sine minus 1 if they want to show 1 over sine. If they want to show 1 over sine, they put huge parentheses and they put minus 1, or they do 1 over. So it's reserved. Around the world, it must not be used any other way except the inverse. Examples. Let's do 1 or 2 examples in 5 minutes. Y equals 7 arcsine of x to the 4. See? Chain rule, right away, you will have product rule, quotient rule. That goes to the test, and it goes to the mastery exam. It's not too bad. I can tell you that. If you finally handle chain rule, it's going to be all the same all the time. So your job is to just understand chain rule once and for all. Y prime equals 7 stays because it was multiplied. Now you see it as arcsine of u, and I told you how to do arcsine of u. All of them have times y prime. You do understand, right? If it's chain rule, then times y prime, times u prime, times u prime, times u prime. You remember, Julia said it was 1 over a square root. And it is either 1 minus input squared or input squared minus 1. And because sine goes first, 1 starts. I don't know, like it's a dumb way to remember. That helps you, good for you. Help me, so I have a bad memory, and that's why I don't do physics and chemistry. No way I'm gonna survive. High respect to people who do physics and chemistry. So it's gonna be 1 minus input squared. X to the 4 is my input. So I say it out loud. Input squared, u squared. So don't mess up. Don't forget it was x to the 4. And then you do times, let me put it in blue, times u prime 4x cubed. Agree? Times derivative of the function inside. Nothing new when it comes to chain rule. Let me write down that this is chain rule. And most students, when they get very good at this, they just write down the square root in the denominator. 1 minus input squared, x to the 8 or x to the 6. What do you think? 8. Because power to the power to the power is multiplied. And then 7 times 4 is 28. X to the cube goes to the top. You don't have to rewrite it like this, but this is just beautiful. It's a short, nice form of simplified. Everything looks amazing. I mean, do you agree? It looks amazing. So that's like, some people get so good at this that they immediately know, since they're going to be one at the top, why not to put everything to the top then, since it's all multiplied anyways. The most common mistake is not to forget that it's x to the 4 squared, not just x squared. So I always say out loud in my classes and when I take derivatives, input squared. Whatever input is, let me put it in yellow, that should be squared. That is just the first example, and we're going to proceed with the domain. There will be restriction of domain. You need to know graphs. What is the graph of arcsine? What is the graph of secant? Arcsecant. We're going to do this boring stuff on Friday. Take care, don't get sick, and I'll see you on Friday. I guess it's not boring, but it's just tedious.